use any units here, okay, unless, so if it hasn't been specified, so for example, if it says 1 centimeter equals 200, okay, you know that 1 centimeter on your map, okay, there's your map, you read off a distance between one location and another location, okay, so for example, you measure that distance there to that distance there, and you see it's going to be 4 centimeters, then you know in real life it's going to be 4 times 200, isn't it? Centimeters. Okay. Yes. So that will be 4 centimeters on your map, and in real life it will be 800 centimeters, right? So 4 centimeters on your map will be 800 centimeters, which is 8 meters. Okay, which is 8 meters. All right, is that okay, everybody? Yeah. Okay. If you don't have, so in this scenario here, when you don't have anything specified, a distance, it means 1 to 200, for example. That means, let's say 1 to 2,000, or let's say 1 to 20,000. You can measure 1 millimeter on your map, and in real life it will be 20,000 millimeters. Okay. So now you just have to convert between millimeters and meters if you want, for example. So how much would that be in meters? How much would 20,000 be in 20,000 millimeters be in meters? Yes, it will be 20 meters. Thank you very much. Good. So in real life, that will be 20 meters. No problem, Nina. Welcome. I'm going to put you on moderate. One moment. Okay, so does that make sense? So you have to be quite confident with converting between meters and millimeters, for example, and centimeters. Okay, so if you had a scale of 1 to, let's say, 50,000. Okay, we're just recapping scales, Lena. We're just recapping scales, scale drawings. Okay, so if you have 1 to 50,000 and you measure to, let's say, 12 millimeters, you measure on your map 12 millimeters, in real life, what would that distance be? So you can see you need to multiply that by 12, so it's like a ratio, you're going to multiply that by 12. Okay, so yes, so that's going to be, if on your map you've measured 12 millimeters. In real life, that's going to be 600,000 millimeters. Okay, so how much would that then be in meters? So well done, Maheen. How much would that be in meters? Sorry, guys, I've just got a bit of a allergy, so I'm just going to disappear for 2 seconds. Okay, yes, so I don't know, it's not really hay fever, I don't think. I don't know what I'm suffering from. It's just a bit of a weird dust or something. No, I don't think it's a cold. I'll survive, inshallah. Yes, so well done, guys. 600 meters, yes? So in terms of meters, that would be 600 meters. Okay. So using the same scale of 1 to 50,000, 1 to 50,000. Imagine in real life you measured something in, you measured a distance of 750 meters. Yeah, there is a distance 750 meters, and you want to now work backwards and work out on your map how large or how long will that distance be. How would you do that? And we're using the same scale of 1 to 50,000. That's 750, 750 just in case, 750 meters. Okay, so Lena, what would that do? Yes, you're yep, correct, but you. Okay, so how on your map, how long would that road? Imagine that's the distance of a road. How long on your road would that, on your map, sorry, would that road be? So you're saying, Saf, what measurement is that? What is your unit there? Okay, so on your map, how long would that be? Okay, that's a large map. That's a large map. Saf. So you're imagine a A3 map, an A3 map. How are you going to fit in real life? This is your distance. How would it fit on the map? Okay, Adam. Yes. So Adam, in millimeters, what would that be? Okay, Saliha, how did you get the same answer as Saf? I've got a different answer to you. Okay. Yes, well done, Maheen. And so in terms of millimeters, so if you want it on your map in millimeters, so I did 750, I converted it to millimeters. Okay, so that becomes this in terms of millimeters. Okay, now I'm going to divide it by the scale. What is the scale factor? 50,000. Okay, does that make sense? Why? Okay, and then this is both in millimeters, right? Okay, that's then going to give me a value in millimeters. Why do you do millimeters? Okay, so I get 15 millimeters. Okay, why do you do millimeters and not centimeters? Hafsa, it's entirely up to you. I simply chose millimeters, okay, but you can do centimeters as well, right? So if you wanted to do centimeters, so if you had 750 meters, you will times it by 100, won't you, Hafsa, yeah? So so that will end up being 75,000 centimeters. Okay, so we're going to divide it by our scale of one. What was our scale? 50,000. So it's going to be 1 to 50,000, isn't it? That's our scale. So we'll divide it by 50,000. Okay. Okay, so therefore I get 1.5 centimeters, which is 15 millimeters, isn't it? Why do you convert 50,000? So Lena, at some point you will have to do that. So for example, if you didn't want to convert, so why? How did you convert? Oh, how did you convert 50,000? Well, because Lena, 50,000 millimeters into, well, think about it, 750 meters, right? In millimeters, 1 meter is 1,000 millimeters, so I have to times it by 1,000, right? So that's how I get the 750,000. Now that's in millimeters, right? So either on my paper I'm going to, my answer is either going to be in millimeters or centimeters. So I can divide it by 50,000 now, okay, and that will give me 15 millimeters. If you don't do that, If you don't do that, so you could do 750. I think maybe Adam, you did it like this, didn't you? Divided by 50,000. Okay, so he got an answer of 0.015, and that will be in meters. That will be in meters. Can you see? Okay, so yes, you can multiply it by 1,000 here to get that in millimeters, or you can multiply it by 100 to get that in centimeters. Okay, so this will give you millimeters, and this will give you centimeters. Okay, so can you understand? It doesn't matter which way you do it. You just have to say to yourself, in real life, okay, there is a distance. Let's say 990 meters. Right. That's correct, Lena. Yep. So you've got 990 meters in real life. Now, if you have a scale of 1 to 250,000, okay, you have to think to yourself, on my map, how many millimeters or centimeters will represent 990 meters, yeah? So first understand that logic, yeah? You are in a field, and there is a road next to a field, for example, it's 990, and you want to use this scale, and you are going to ask yourself, on my map, on my piece of paper, how long will that road be? Okay, so how you will do that is you will decide if you want it in centimeters or if you want it in millimeters. Whatever you decide, you have to make that conversion. You either do it now or after, it's up to you, whatever you find easy. So you can say, okay, I want it in millimeters, let me times it by 1,000. Yep. So now that's going to give me 990,000. Okay, so there is my 990 meters now in millimeters, yeah? There's my 990 meters in millimeters, yep. So I have to use this scale and divide it by 250,000, and that will give me, so this is the scale, yep, that's the scale factor. Scale factor. That will give me how long that will be on the piece of paper. 250,000. Okay, so it's going to be 3.96 millimeters. So it's very small on the map. Okay, does that make sense, guys? Okay, so that's very important. I'm not going to dwell upon this too much. Have a go through the video, or watch the video again if you're a bit shaky, to try and make sense of it, inshallah, and to also retain this information. So you need to know how to do it both ways, okay, guys? From the map into real life, from real life back onto the map. Okay, so both ways. Right. So the other. Okay, the other thing I wanted to cover. So remember, these are smaller topics. So I'm trying to get through these little niggly topics. Let me just. Okay, we're going to look at construction. So you might need, well, you will probably need yourself a compass and a ruler. So we've, I think this is also KS3 content as well, but it's also part of GCSEs. It doesn't get much harder, but I'm going to quickly whiz through this because I have seen these questions pop up, and it's a shame that if I don't go through it and you lose marks on something which is quite easy to get. Okay, so okay, Lena remembers this. Good. Okay, so if you want to construct a triangle, yep. So we've got draw. This is example ABC, triangle ABC. It gives you the value of AB. BC is 2.5 and AC is 2 centimeters. So what you're going to do is simply draw your baseline. Okay, so you're going to think your triangle is going to look like this: A to B, B to C, A to B. Why is it so big? Hold on. So we've got A to B, yeah, that's your baseline. You got your A to C, and you got your B to C, yeah. So that's your triangle there, right? So that's what you're going to imagine in your head before you start. So you draw your baseline of go with your ruler, get your ruler out, make sure it's accurate. You draw 3 centimeters, and then what you do is the other length here, which is going to be 2.5, you stick your compass, the sharp end. I don't need to show you, I don't think. You can see in this diagram there, there's your sharp end, the pencil end, and you draw yourself that arc, yes? You draw yourself that arc. So that gives you exactly, that distance there will be exactly 2.5. You obviously measure that, guys. Sorry, did I not mention that? You measure that to be 2.5. Does that make sense? Yeah, so you open up your I don't have one with me. You open up your compass and you put it on a ruler. So imagine that's your compass. And you measure 2.5. Okay, and then you stick the sharp end at the end of the line AB, draw yourself an arc. Then you get the other dimension, which is 2, right? So again, you'll do the same thing, get your ruler and get your compass, and you'll measure 2 centimeters. You'll stick the end here, the sharp end, and you'll draw yourself another arc, yes? So that arc will kind of intersect there at some point, yeah? Those 2 arcs will cross, as you can see in C, right? This point here. And then you simply get your ruler out and join up and join up. Yeah. So now, once you've got that, you've got yourself a perfect triangle. Leave your little arches there. It shows the examiner that you've done the proper, you've used the proper process. So that will give you an exact triangle with those dimensions. Okay. Right. Let's consider these triangles here. Let's take this one here in question exercise 1. Okay, so have a quick go at drawing that accurately in your books. Shouldn't be that hard, should it? And let me know if you are okay with that and how you get on. So that's going to be pretty straightforward. You don't actually have to, yeah, that's going to be pretty straightforward. What you're going to do there is, we're doing question A. Yes, you're going to draw question A, Lena. You're going to do question A. So you're simply going to measure, and if you measure this at a 90-degree angle, okay, and then you've got this length here. I guess this will be pretty straightforward to draw. You can just measure them all out. So don't worry too much about question A. It's not that difficult. Okay, once you've got this length here, okay, when you've got that length there, and you can just join it up like that. Okay, so just make sure you get exactly a 90-degree angle. Okay, so for question B, you're going to draw your baseline. You're going to measure that point as being 4.5. You're going to draw your arc. You're going to measure this as 3, and you're going to draw your arc there. Okay, and then you're going to join those points up just like that. Okay, do we have to go through it, or are you guys okay? You can perhaps practice after, right? Okay, good. We don't need to spend too much time on this. Just to refresh and remind you guys, Okay, so if we're going to look at constructing a perpendicular bisector, what that is that you got this line here, and you got, let's say firstly you got this line here, and you want to cut this in half exactly at a 90-degree angle. Okay, so that's exactly a half. So that and that is equal. Okay, that side and that side is exactly equal. Yes. Okay, so what we are going to do is, as you can see here, we are going to draw ourselves a 3 centimeter line. Yeah, so the question says draw a line AB, which is 3 centimeters long, and construct its perpendicular bisector. So you're going to, after you've drawn it, you're going to place a compass at point A with the radius set at, so just make sure your radius, okay, so that's the distance. Yeah, so your radius is going to be that distance there, yeah, so of your compass. So you're going to make it more than halfway between A and B. So let's just say somewhere like over 1.5. Okay, 1.7, just slightly over. So measure that, or just put it on your line being halfway. Okay, and yes, you're going to draw yourself this line here, this arc, and then you're going to do it on the other side as well. So keep the compass the same. Do not move the radius. Okay, and then you will draw your arc like that. Okay, and you'll draw one like this as well. Okay, so you'll spin it around. Okay, and then you're just going to join those points up there. Exactly, Maheen, good. So that's pretty simple, right? So that will guarantee that this line is at 90 degrees to this, so it's perpendicular, and it's bisecting. It's a bi means like two. It's bisecting it halfway in the middle. Okay, so again, measure with your ruler, get your compass halfway there, over halfway, draw yourself that arc and that arc, switch it around to this side, draw yourself that arc, draw a line right between the two. Simple as that, yes? So that will give you your perpendicular bisector. Okay, so you can practice exercise 2 perhaps for homework or whatever you want on your own. Okay, any issues there? Are you guys okay with that? If you are, I can explain it a bit further. If not, then we're good to move on. Okay, look at this one here now. Constructing an angular bisector. So the angle bisector is exactly half. Yeah, so that's 30 degrees going to be cut into half. Yeah, so what you are going to do, very similar, is you are going to get your compass and you're going to put the sharp point there, and you're going to open the compass so it's beyond halfway, and then you're going to construct yourself an arc there and an arc there. Okay, and then you are going to put the compass again on that point there. Okay, and you're going to draw yourself another arc there. Then you're going to do the same to the other side. You're going to draw yourself an arc there. Put your compass there. Do not change the radius. Okay, and you're going to draw yourself another arch there. Okay, so that will give you those. Oops, that will give you those 2 points. But obviously, I haven't done it properly. That will give you those 2 points that you need to cut that angle exactly in half. Okay, I know I went through that very quickly, but is that clear, guys? Are you guys okay with that? Shall I explain it again? Ooh, yeah. Yeah, no, it's clear. Okay, good. All right, so we're not going to dwell upon that, but I'm just going through it so you guys can remember. Okay, so let's look at this. This is constructing a perpendicular from a point to a line. Okay, so this is point X, yes? So this is a scenario here. Look, we've got X, they've given you X, and they've given you a line A and B. So it says construct a perpendicular from point X to the line A and B. Okay, so what we are going to do, we're going to do a similar thing, right? We're going to put our compass here, the sharp point there, and then we are going to draw an arc like that. Yes. Do you guys have you guys done this? So I haven't got the notes beneath it, but I hope you remember this. And if you can, do you guys recognize the difference as well between the question? Can you see the difference? Yes. Okay. Good. So once you've drawn your arc, you're going to get your compass again, and you're going to put it on the parts that where it crosses. Yeah. So it crosses here. Yes. So you're going to draw yourself another arc there, and you're going to put your compass there again, and you're going to draw another arc there. Okay. So then you get your ruler out and you draw your line straight until it cuts that point there. From X all the way to that point there. That will give you a perpendicular line from that point X. It's not necessarily, I don't think it gives you a bisecting one, so it doesn't cut it necessarily in half, but it's from the point X. That's what matters, because X may not be in the middle, X may be there. Okay? So it won't necessarily cut that line in half, but it will give you a perpendicular line from the point X to the line A and B. So we know that will therefore be 90 degrees. Okay, so again, just very, very briefly, you have got your point X here, you've got your line there, you get your compass like that, okay, and you construct yourself an arc like this, and then you get your compass again, put it there, do yourself another arc like that, put it there, get yourself another arc like that. Okay, and then that line there, you join up with the points at where it crosses over. Obviously, mine is not drawn to it properly. And then that's a 90 degree from that point X. Okay, so pretty straightforward, guys. Any other issues with that? No? Good, okay. So we've covered that topic now. Hopefully it's going to be something that sticks with you, inshallah. So we're going to move on now. In tomorrow's lesson for the 2019, I'm planning I'm planning to go through sequences. Okay, so that's something we need to cover. So please make sure you attend tomorrow's 2019 lesson. Okay, so that's very important if you can make that lesson there tomorrow. Okay, sorry, I'm just trying to upload another worksheet and it's not letting me show. Oops, sorry. Tomorrow's lesson is going to be at 10:15. Okay, okay. So we're going to do Assalamu alaikum. Sorry about that. Somebody pull the router plug out. Are you all here? Can you all hear me? No, router was disconnected. Sorry, the power cable was disconnected. Right. So we're going to look at congruence and similarity. Again, very common question in the exam. Very common question, kind of topic in the exam. So it's something we need to cover. Maheen, you've come across this, right? Yeah, good. Right. Okay. So tomorrow's lesson, inshallah, 2019, we're going to be doing sequences. That's a biggish topic. So we need to cover that. These are little small topics here and there. And then we need to also cover probability and histograms. So once we've done all of that, inshallah, I hope that's the majority and the bulk of all of the content. So we can just start hitting past papers, inshallah. Right. Okay. So let's take a look at this topic. Right, so congruent shapes are exactly the same shape and size. The images of rotated and reflected shapes are congruence of the original shape. Okay, so that's just telling you that if a shape is a triangle with x or with certain dimensions, just because you rotate it by this, okay, it's still the same shape. Okay, so that's called a congruent. Same thing. Okay, if all the dimensions are the same, okay, it's the same shape. So it's just called a congruent. So you can see there they've shown you that this angle here is the same angle, but you can see it's just been rotated by a certain angle. Okay, so similar shapes are exactly the same shape but different sizes. So it can be scaled down or it can be scaled up. Similar shapes can be in different orientations, so it can be changed, the angle of it can have changed, or the positioning. The image of a shape after it has been enlarged is similar to the shape. Okay. So here, let's just have a look quickly what they're saying here. The two triangles are congruent if they satisfy any of the following conditions. Okay, so we've got side, angle, side. So two sides, and the angle between on one triangle are the same as two sides, and the angles between on the other triangle. Okay, so basically this and this, okay, and this are the same here, here, and here. So that's all it's really saying in a kind of roundabout way. Okay, side, side, and side. The reason why that is because obviously if you've got, sorry, one second, if you've got this angle, this side and this side, the same as this angle, this side and this side, then this line has to be of a certain dimension. That angle there has to be of a certain dimension. So it doesn't matter which way around it is, it's going to always be the same. Okay. How about this scenario here? A, B, and C. So if they're all the same, obviously they are the same triangles, right? If that is the same as that, that is the same as that, and that is the same as that, obviously it's the same triangle. Here we've got two angles and a side, so we've got these two angles, and this side will force that angle to be of a certain angle, and it will force this to be of a certain length, because you're only limited at what you can, you've only got 180 degrees in the triangle, haven't you? Okay, so if this one has been given, then this one has to also be the same. And also here, right angle, hypotenuse, and side. So if you've got this here and this are identical, obviously we've got 90-degree angle there, and the hypotenuse, both are the same, then obviously that will have to be of a certain angle, okay, because of the limitation. You've only got 180 degrees in an angle, in triangle, and you've been given this length and this length. It's going to force both of them to be the same, so they have to be the same. Right, okay, so let's look at example one. Example one, are these two triangles congruent? You can see, right, that this and this, both angles are the same. these two lengths are the same. Yes, 2 and 2, 4 and 4. So yes, maybe I'll zoom in. So you can see that both triangles are congruent. Okay, any questions up so far? I know I'm going through this pretty quick because this is quite straightforward so far. If it does get a bit more complex, I will clarify a bit. Okay, but I feel I need to as of yet. Okay, so that was example 1. The following pairs of triangles are congruent. Find the value of the angles and sides marked with letters. So this triangle and that triangle are the same. You can see, because they're the same triangles, you can take the information from this triangle and find out the unknowns from that one, and the information from here, and you can work out the unknowns for this triangle. Yeah. So yes, well done, Maheen. Good. So can you tell me the value of D? Can you answer what the value of D is? Okay, yes, so in exercise 1, question 1, the angle D is going to be 32, and both of those are going to be 74, right? So both are going to be 74, B and C. There we go. Okay, so how about this one here, B? We've got this angle here, this angle here. So can you work out the length of H in this particular case, and the value of L? And the value of J, so those unknowns. Okay, Adam, correct, good, well done. Okay, yes, so we've got 8, right? This here and this here are corresponding, right? So J, indeed, well done, is going to equal 8 centimeters. What else do we have? We want to find the value of L. So L equals, yes, well done, Adam, good. Okay, so L is going to equal 57. L equals 57. What about the value of K? The angle, sorry, angle K. K equals? Yes, K is equal to G. Yeah, so what would the angle be? If you've got this angle and you've got this angle, K and G are going to be 57, isn't it, plus the 90, and you take that away from 180, so it's 33. So K equals G, which equals 33. And what else do we have? We don't have, or what do we need to find? We've got K, got G, L, I think that's it, H. What was H? H equals 6. Good, well done, 6 centimeters. Okay, so pretty easy, not that complex. Okay. Okay, we'll have a quick look at question 2. We'll look at A. For each of the following, decide whether the two triangles are congruent. In each case, explain either how you know they are congruent or why they must not be. So let's look at question A. Do you think they're congruent? Yes. you can see, right? So you don't have to really explain that much. You can see those angles same, just flip upside down. That and that are the same, that and that are the same. So you can say they are congruent. Yeah, so if you get anything like this in an exam, just give a bit of explanation, yes? If you have an exam, just give a bit of explanation. Those sides are both the same, the angles are exactly, the angle is both the same, so we have two sides the same and an angle the same, so that shows it's congruent. How about H? Is H congruent? The two triangles in H, are they congruent? Okay, that's pretty evident, isn't it? You can see almost instantly this has got a right angle in there. Okay, this does not correspond. Well, it could correspond with, oh, there is a right angle maybe. Okay, there is a, yeah, we could say it's a right angle. Okay, but it should show it really, so you can't be too sure that's a right angle, so let's not guess there. Okay, but we can work the angle out, can't we? So let's not guess, but let's just be a bit sure. Let's be a bit sure. So we've got 49 and 41, right? So those two together are going to give us 49, and we've got the 41 are going to give us 9. Oh, so that is a 90 degree. So not by inspection, but by calculation, you can see that's 90 degree, isn't it? This is 21. And this is 21. Sorry, I made a mistake at the beginning. I jumped and thought it wasn't congruent, but now looking at it, yeah, that's why you shouldn't be too hasty. You can see that as the same, right? So 21, 21, that's a right angle, that's a right angle. So you can see this is, we've got the two angles now, 49 and 41. So yes, these two are congruent. So just be careful in how you do that. Okay, so we don't need to spend too much time. We're not going to look at exercise 2. Let's look at similar triangles. This is where this is the very kind of common exam question or topic, similar triangles. Okay, so it says two triangles are similar if they satisfy any one of the following conditions. If two triangles are similar, then all the conditions are true. So for example, in this particular case here, all the angles on the triangle are the same. Okay, so if they're the same, then these two triangles are similar. Okay. How about in this scenario here? What can you see? This is A, this is 2A, this is C, this is 2C, this is B, this is 2B. So what does that tell you about those two triangles? That they are similar. Although, yes, one is an enlargement of the other, isn't it? One is just like a scaled up version. Yeah, there we go. There's baby triangle and there's Baba triangle. Okay, so all these sides on one triangle are in the same ratio as the corresponding sides on the other triangle. Okay, look at this one here. It's going to be the same thing. So two sides on one triangle. So that side and that side, two of those sides on one triangle, are in the same ratio as the corresponding sides on the other triangle, and the angle between is the same. Yeah, so that angle's got to be the same. It's not going to be any different. So this isn't going to be double, it's going to be the same. Yeah, does that make sense? So don't assume that's going to be double. If it were to be or half, yeah, this one and that one have to be the same, because just because that triangle goes on and becomes a larger triangle, the angle is still going to be the same. Okay, any questions so far? People are a bit quiet today, even in other classes. Is it because it's meant to be a holiday? Okay, good. Oh, everybody's in holiday spirit, right? But you guys have got your exam coming up. Sorry. No holiday mode for you guys, I'm afraid. You guys have got more on your plate than them, you know, the rest of the people, yeah? You got more on your plate. So what does that tell you? That means you're growing up. That's what growing up is about. That's all about growing up. You start having less of these holidays and less responsibility and less fun. Yep, it's all part of growing up. Yep, I keep telling the other guys, you know what, it's hard work growing up, but no one believes me. And some of the kids through like, oh, I can't wait to be an adult. I was like, really? They think you can do whatever you want as an adult. Because you don't have to go to school. Because you don't have to go to school. They think like it's all rosy. Exactly, you have to go to work and pay bills and look after children. And you got to put up with their nonsense, isn't it? You got to deal with their nonsense. Okay. Salih, I'm afraid there's no escaping growing up, you know. There's no escaping. Look at these two triangles. Yeah, the grass looks green on the other side. They think it's rosy and green on this side of life, but no. Okay, these two triangles, we've got this same angle, I think, 90, 90, 40, 40, 50, 50. All the angles in one triangle are the same as the other angles in the other triangle, so the triangles are similar, okay? Just because those lengths are different, what dictates those lengths, I suppose, is going to be those angles, isn't it, really? Because you can't get away. Those lengths will be of a certain size because of those angles. Okay, exercise 3. For each of the following, decide whether the two triangles are similar. Okay, we won't go through all of these. Are these two similar? So we've got 55, 55. We've got 80. Ah, look, we've got 87 and 38. Oh, they tried to trick us there. Okay, so those aren't similar. How about B? How about B? Okay, you guys sure? Sure about your answer there? Yeah, I think we could say that they are similar, right? Yeah, I think we could say that they are similar because it's just a scaled up version, isn't it? And we can see that the scale is constant throughout for each dimension. So this one here and this one here are the same, but this is 1.5 times, right? 1.5 times. This likewise is 1.5 times. Yeah. How did you work out it's 1.5 times? Well, you can just do 6 divided by 4 equals 1.5. You can get the 6 with the corresponding. Those are both the same. 12 corresponds with the 8, doesn't it? So that's going to be 1.5. Yes. So well done, Maheen. Good. Okay. So be careful with that one there. So those angles likewise will all be the same and so on. So be careful on question B. What does 1.5 got to do with it? Lena, that's the scale, yeah? That's big brother, little sister. Yeah, big brother, little sister. There's a ratio of 1.5. They're the same. Can you see they look exactly the same? Yeah, that's like you and your little sister. Lena and what's that? Husna, that's the one, yeah. Right, okay, so just careful about that. How about D? Are these the same? Oh, Husna's always angry. Don't worry about her. Husna is always got something to moan about. Asia, me and Asia. You have another sister called Asia? Okay, so are these, we've got the same angle there. Is there any type of relationship between the two? Are those the same? Yeah, the angle is the same, but we can't really work out a relationship, can we? Can we get a relationship? No, we can't. The angle is the same, okay, but there is no constant relationship. There is no constant relationship, is it? Between that one and that one, as well as, yeah, so there's no, so you have to make sure that relationship is the same. Okay, so yeah, so in the end, finally, the answer D is that they are not the same or not similar. The side lengths can't be in the same ratio as two sides of the first triangle are equal, but the sides in the second triangle are all different. Okay, so for D, that's not going to be similar. Right, okay, so let's look at exercise 4. Oh, it's tough life, Saliha. Is everyone playing out playing out? Yeah, she's moaning. Everyone's playing out. Okay, so look at these two. We've got these two triangles. It says show that angles A and B are similar. Angles A and B, triangles A and B are similar. So how could we show that those two triangles are similar? Let me just. Yeah, there we go. Let me just put it on the screen so you can all see. Yeah, okay, because we have this 90-degree angle there, we have this 90-degree angle there, so that's good. We have this here, which corresponds to that. So yes, well done, Saf. It seems to be, it's going to be 2 times, isn't it? 2 times that length. There's a factor of 2, isn't it? And so what would you, this length here is going to have to probably be 26 then, isn't it? Okay, and how about this length here? Okay, yep, so yeah, we can work out all those values there. So we could also work out from Pythagoras' theorem the missing side of triangle A. Yeah, okay, so from here, yeah, so we could work out from Pythagoras' theorem there that, so we can say 12 squared, 13 squared take away the 12 squared will give us A squared, won't it? So we can work it out like that as well, just to be sure. So 13 squared, and then we're going to minus 12 squared, yeah, and we get 25. So root the answer and we get 5, okay? So we can see this is going to be 5, and this is 10. Okay, so that would probably be the best and safest way to go about this. Work out or find out what you can work out, and then you can see just to make sure, okay, look, this is half of that. So there is a factor of 2 between these two, yeah? So this is double that. Anything else? Okay. A, B, C, D is an isosceles trapezium. Yep, here we go, A, B, C, D. So therefore, this and this are parallel. This and this are the same. Prove that the triangles BEC, there's B, E, C, and AED, these two triangles, yeah, prove that the BEC and AED are similar. So, how could you prove that they are similar from your understanding of geometry and from what you can see there? Yeah, okay, so one is larger than the other, indeed, good. Oh, sorry guys, I just lost connection there. Okay, we are here. Let me just... Can you all hear me? Okay, good. Right, okay, so we're going to say, how do we prove this? So we need a bit of explanation here, guys. You can't just say they look the same or one's a bit bigger. You need to use a bit of explanation. Okay, so you can say that BE and C equals angle AED. They are vertically opposite, so you might want to mention that. And then you can say A and D equals, so angle A, so let's look at angle A, DE, okay, which is this one here, angle A, D, E, okay, this one here, angle A, D, E, yeah. Okay, from similar triangles is equal to that one there, can you see? Sorry, from, not from similar, sorry, from alternate angles, yeah? So alternate angles, this and that equal the same, can you see? So you've got to try and remember your understanding from previous topics like alternate angles, yeah? So remember alternate angles. Because these two lines are parallel, yeah? For alternate angles to be true, these two lines have to be parallel, don't they? Then that line there and that, that angle there and that angle there are going to be the same. Okay, so Lena is saying, wouldn't angle AED and BEC, so I think you mean EAD, yeah? This angle here as well, don't you? Mean that one? Yeah, so remember, so just, Saf, can you see what I'm writing? Can anybody else see what I'm writing? I'm scribbling. Okay, so Saf, I think it's just perhaps your connection. Okay, so just be very careful, guys, when you are specifying your angles, all right? So if I want to specify this angle, that angle is going to be, what is that angle going to be? How would you specify that angle? What's it called? Because I think, I mean, for example, if you try and write something in your exam and you don't call that angle up by its correct name, you will confuse the examiner. So this angle here, what is that angle there called? Well done, Maheen. Good. Anybody else? Adam, good. Yeah. So what's it called? Not its. I'm not asking for the measurement, but what's it called? Okay. So that angle is going to be EAD. Yeah. That's how you call it up. EAD. So the middle angle A there is in the middle because it makes the angle, yes? It makes the angle. So I think Maheen, no, Lena, what were you? Which angle were you referring to? Which angle were you referring to? AED. Okay, so this one here. Okay, yes, those two also will be the same, won't they? Because that and that will be the same. So I'm just making sure you are using the correct angles, correct names. Okay, so from alternate angles, if we know this one here and this one here the same, this one here and this one here the same, this one here and this one here the same, we know that those are similar triangles. Okay, so you want to be able to prove and use that as an explanation. Right, okay guys, so let's look at example 3 now. We've got triangle ABCDEF, okay, here and here. It says the triangles are similar, so that's very important. It's been given to you. Excuse me, guys, for 1 second. I just need to see. Sorry. Right. So what we're going to do is we're going to do the same thing. Because it's told us that these are similar, it's been given to us, we can work out the scale factor, can't we, from this and this. They're corresponding, yeah? Yes, thank you very much, Lena. I didn't even end up sneezing, would you believe it? Thank you. So we've got these two angles are the same, and so we can work out this, can't we? We can work out this length. And we can work out this length, can't we? Yeah, pretty straightforward. So be aware of that statement there where they say that they are similar triangles. What else? Okay, so we have this here, for example, triangles PQR and UVW, sorry. So it says again, that's the key to this question, that word in there. They are similar. So we are going to find this angle here, right? We are going to find this angle here. So what we can do is we can say this angle and this angle are obviously corresponding. This one and this one are corresponding. And so we're just going to take this these two values away from 180. We can get that one quite easily, can't we? So that gives us 40. So we can see the angle X is likewise going to equal 40 because they are similar triangles and the values of the angles will be the same. Okay, exercise 5. Have a quick go through that. So we've got this. They are again similar because it says in the question. This is 35. This is 35. This is 8. This is 4. This is 8. So this is going to be. This is 2 times this. So what does it ask us to do? It says find the ratio of the length x, y, and PQ. So you can see what that ratio is. What is the ratio? Yeah, it's double, isn't it? It says 1 to 2. 2 times this one here. So we can find what the value of YZ is, can't we? Yes, so well done, Lena. Pretty straightforward. Okay, that's going to be 6. Okay, now check this scenario out. We've got the diagram here. We've got this triangle. It shows 2 similar triangles. So that's going to be this triangle inside and the greater triangle on the outside. Not drawn very well, but you understand, yeah? That triangle there inside and the overall triangle. Yes, this one is baby and mummy according to baby and mummy according to Lena. Okay. So we've got these 2 triangles here. Find the ratio of the length AB to the length AD. So you can see what the ratio is going to be. AB to length AD. Yep, so you can see A to D, yep, is going to be double A to B, yeah? So therefore we can work out what BC is. So then it says find the length AE. Where is AE? AE is this whole length here. So you can see what that's going to be. Yeah, it's going to be double 6. What else does it ask us? Find the length BC. So BC is going to be 6 there. Okay, so yeah, so pretty straightforward. 3, 3, 6. Okay, yeah, that makes sense. Yeah, so we divide it by 2, yeah, because there is a scale factor of 2. How about here? We've got the diagram below. Am I moving too fast, or you guys are okay so far? Yeah. Yes, we are on a roll. We have to be on a roll because you guys have got your exam coming up soon. Okay, good. We've got this ST. What is it? The diagram below shows 2 similar triangles. Okay, there we go. There we go. Find the following lengths. So we're going to find ST. Where is ST? That length there. Okay, pretty straightforward. Okay. Yep, so it's going to be, there seems to be this relationship of double again. Okay, so we can find out all those values, can't we, from from that there. So A is going to be 6, yes. A is going to be 6, so ST is 6. Why does that keep going small? And it's doing it again, sorry. Yes, so QT is going to be 10 and UT is going to be 5. Good, brilliant. Okay, so all those are quite straightforward. Lena, do you want a break? Lena's trying to go to the garden. She's trying to get into the garden. No, thank you. I'm okay. I have to make sure you guys understand this topic. So, oh yes. So we have, in fact, we've come to the end more or less now, anyway, haven't we? Okay. So, just very, very quickly. Have we got time for this? Okay, we'll do this next lesson. 32.2. We'll go through this the next lesson. And tomorrow, remember, tomorrow we're going to be doing sequences. For 2019, I advise you guys to come to attend. We're going to be doing sequences. And what else have we got to do? Probability and histograms. We're going to wrap this all up, inshallah, so we can start revising over past papers or going over past papers. Okay, any questions? Salih had tomorrow sequences 2019, so please come along if you can, inshallah. Okay, Jazakumullah khair and Assalamu alaikum wa rahmatullahi wa barakatuh. Yes, 10:15. 10:15 tomorrow.